Hi, my name is Holly, and I'm a postdoctoral researcher from Erasmus Medical Center in the Netherlands. And today I'm going to be talking about autistic traits and nutrition behaviors in the pediatric population. So far in the symposium, April and Rachel have focused on children who have already been diagnosed with autism or a related condition. But I'm going to outline the difference between an autism spectrum disorder diagnosis, or ASD, and autistic traits in the general population. And then I'm going to talk about what we currently know about nutrition behaviors in children with ASD and highlight some research gaps there too. And then I will talk about how we can leverage epidemiological studies to fill some of these gaps. And I'm going to introduce to you the Generation R study. And using this cohort, I'm going to look at two studies which will provide empirical evidence of how we can look at autistic traits and nutrition behaviors at the population level. And then I'm going to conclude with some brief remarks about implications. This is a simple visualization of the frequency in which the severity of autistic traits continuously are distributed in the general population. At the most severe end of the spectrum, functioning may be impaired and manifest in an ASD diagnosis. And just to give you an idea, the worldwide prevalence of ASD is 1%. So ASD requires that two core criteria are met. Firstly, persistent deficits in social communication and interaction, and then secondly, repetitive and restrictive behavior. Some children have elevated autistic traits, but they don't quite meet that clinical cutoff for ASD diagnosis. And so these autistic traits parallel the core ASD symptoms, but they're more subtle in expression, and they're usually not associated with functional impairment. Children with an ASD diagnosis are 5 times more likely to experience eating or feeding problems compared to neurotypical children. So eating problems can include things like food selectivity or picky eating, where only a narrow variety of food is consumed, food refusal, disruptive mealtime behavior, slow eating, late acceptance of solids, and food neophobia. And while many ASD interventions focus on cognitive, behavioral, and language outcomes, eating problems remain an undertreated and an under-recognized symptom of autism. But eating problems also exist in children without an ASD diagnosis, but they may be age-dependent. So for example, children will generally grow out of a picky eating phase early in life, but this may persist in children with ASD. Given that autistic traits are distributed on a continuum across the population, this begs the question if eating problems are proportional to the severity of autistic traits on a continuum as well. So research to date has just mainly compared nutrition behaviors in children with to those without ASD. So these studies generally show that children with ASD tend to have lower dietary variety, consume less nutrients, tend to be overweight and underweight depending on the age of the child, and also have a greater risk of developing eating disorders such as anorexia nervosa or avoidant and restrictive food intake disorder, or ARFID. Such research that compares those with to those without ASD overlooks that continuum of autistic traits in the general population, and they assume eating problems to be a part of ASD. And they don't actually consider the possibility that eating problems may precede the emergence of autistic symptoms or even exacerbate these symptoms. Recruitment of children with ASD may also underrepresent girls who are underdiagnosed or tend to mask their symptoms, or who just may present with different symptoms. And finally, much research to date is based on cross-sectional or case control studies with scant evidence from longitudinal studies and very few from population-based studies. Large epidemiological studies like Generation R, which I will be presenting on to today, can be helpful to fill some of these gaps. So mothers in Generation R were recruited prenatally, and children were followed up repeatedly throughout development. I'm going to focus today on measurements that are taken at several time points postnatally, depending on the availability of the measures. As I mentioned, I'm going to focus on 2 studies in order to understand the process of the development of autistic traits and eating behaviours, but then also examine the dietary outcomes associated with these processes. In study 1, my colleagues, who are pictured here, and I examined the bidirectional association between autistic traits and eating problems across childhood. In study 2, my colleagues and I examined the association between autistic traits and diet quality, and then we wanted to explore the mediating role of food selectivity. So we decided to zoom in on the role of food selectivity because it's the most common feeding problem in children with ASD. So, in the first study examining bidirectional associations, we used 5 repeated measures of autistic traits and eating problems, which were self-reported by parents on the child behaviour checklist. Measures were taken at 1.5, 3, 6, 10 and 14 years, and data was available for 4,930 participants. So to investigate bidirectionality, we used the random intercept cross-lag panel model. So this is a type of structural equation modelling that allows us to tease out stable between-person effects from those within-person deviations over time. So basically, we want to examine how an individual deviates from their own average score of autistic traits at one wave and how this is associated with deviations from their own average score of eating problems at the following wave and vice versa. So this is the results of the random intercept cross-lag panel model, which show good model fit. And the values that are pictured here are the significant pathways. So these are the standardized betas for each pathway. So firstly, this model shows us that at the between-person level, the positive covariance between autistic traits and eating problems indicates that children with higher average scores on autistic traits also had higher average scores on eating problems across all waves. Okay, so now the most important findings here is what is happening at the within-person level. There was evidence of a small but positive bidirectional association between autistic traits and eating problems from 1.5 to 3 years old. So this means individual children with greater than their average levels of autistic traits at 1.5 had greater than their average eating problems at 3 years old and vice versa. So we also found evidence of a small unidirectional lagged effect between the ages of 3 to 10. From 3 to 6 years, eating problems positively predicted increases in autistic traits. And then from 6 years to 10 years, there was a negative association between for eating problems predicting autistic traits at 10 years. So this is a little difficult to explain, but it's not completely uncommon in this type of modelling. So further research here is needed. So to answer the first aim, we indeed did find a bidirectional effect between autistic traits and eating problems in the early toddler years. So we think this is because children with atypical sensory sensitivities, delays in motor development, difficulties in communicating their food preferences to caregivers, and a need for sameness may find eating more challenging, and this could reinforce early eating problems. All right, so moving on to the aim for study 2. So we had data available for 4,092 participants. And I'm going to break up the analyses into 2 parts. Firstly, I'm going to talk about the association between early autistic traits and diet quality. And then secondly, we're going to look at the mediating role of food selectivity. Parent-reported autistic traits were examined at 1.5, 3, and 6 years old. Diet quality score is measured at 8 years via a parent-reported food frequency questionnaire. So development of this diet quality scoring has been previously defined in Generation R. And just to summarize this, ratios of reported intake to the recommended national intake was calculated for 10 food components outlined in the slide here. But there were limits on sugar-containing beverages and meat recommended in the national guidelines, so therefore this was reverse-coded. So I'm going to present the following results showing coefficients that have been adjusted for child sex, age, energy intake, ethnicity, birth weight, BMI Z score, maternal age, and education. As a first step, we examined autistic trait trajectory using latent class growth modelling, and we found two classes. So you can see here 5% of the total sample fell into the group with high and increasing average levels of autistic traits, and the remaining of the sample fell into the low and stable group. In our analyses, we found that children in the high and increasing group had poorer diet quality at 8 years, with dietary quality scores being 0.28 standard deviations lower compared to the low and stable group. We also modeled these associations between each autistic trait score at each year and dietary quality score in separate multiple linear regression models. And what you see here is weaker compared to the previous slide, but still an inverse linear association between autistic trait severity at every age and diet quality score at 8 years. Okay, so moving on to the second part of the second aim, we use an early measure of autistic traits, so here in 1.5 years, and we introduce food selectivity as a mediator, which was measured at 4 years by the food fussiness subscale of the Children's Eating Behaviour Questionnaire. In the analysis, we found that more severe autistic traits were indirectly related to poorer dietary quality through increased expression of food selectivity. So in the diagram here, I am showing the standardized betas and the 95% confidence intervals. So we found 43% of the total effect of autistic traits on diet quality is explained by the indirect effect of food selectivity. What we learnt from the second study is that early expression of autistic traits was associated with poor dietary quality in mid-childhood. And food selectivity may indeed be a behavioural factor, which explains a high proportion of this association at the population level. Okay, I'm going to leave you with 3 key implications derived from the findings of both studies presented. Firstly, findings suggest that before the age of 3, there may be a sensitive window for opportunity for intervention on early autistic traits and eating problems. But we need to investigate whether these interventions can change the course of development of autistic traits or eating problems. Secondly, we can perhaps better identify more mild forms of autism early on in toddlerhood by screening for specific eating problems associated with autistic traits or by monitoring an autistic trait trajectory. So tool development here is required. And finally, we need to evaluate interventions which focus on food selectivity as a behavioural target for intervention. So addressing eating problems may improve children's ability to cope with atypical sensory sensitivity and the social demands of mealtimes, which could reduce stress in the family and promote children's nutrition. All right, so thank you very much for listening to my presentation. I would like to acknowledge my co-authors, especially Pauline Jansen, who is my supervisor, and my funding sources, and of course, the children and families who participated in Generation R, as well as the research team. Thank you.